Well, good afternoon, everyone. I'm Ryan Siegel. I'm here with my colleague, Sean Maurer. We're with the Smart Energy Design Assistance Center at the University of Illinois, housed at Urbana-Champaign. And today we're going to be talking about residential energy code here in the state of Illinois. And so a few reminders before we begin that today's session is being recorded, and today's recording along with the PDF of today's slides will be uploaded to our website, SEDAC.org. Everyone will receive a certificate of attendance for today's workshop. And for those of you who may need ICC or AIA credits, when you receive your certificate of attendance for today, go ahead and reply back with your ICC or AIA number, and we will go ahead and get those reported for you. We will note that the systems are taking a little bit of time, so if they don't show up right away as far as the AIA or ICC credits, please give that a few days and maybe up to a week or two before those may show up on your system. So certificates of completion should come out here by the end of this week. So as far as what we're going to cover today, looking at the energy code changes moving from the 2015 up to the 2018 version of the International Energy Conservation Code, and specifically looking at the Illinois provisions and looking at potential compliance issues and concerns, and with the goal here being to understand how to comply with the current Illinois Energy Conservation Code. So a little bit as far as who we are. As noted earlier, we're housed at the University of Illinois, and our primary mission is to reduce the energy footprint of the state of Illinois and beyond. So that's both public and private sector. And so providing training on the energy code is one methodology that we do that. So we do want to thank today's sponsor. This program is sponsored in part by the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency. So if you do need assistance, please feel free to reach out to us at SEDAC. We do have several methods that you can reach out to us if you do have questions, predominantly through our email address, energycode@sedac.org. We're here to provide technical assistance. This includes for code officials, design professionals, building owners, occupants, and operators. So if you do have questions and need some technical support for the Illinois Energy Code, feel free to reach out to us. Again, energycode@sedac.org. We do have an 800 number if you need. But at our website, we do have several online resources, including archives of our previous workshops as well as webinars. And so that's also where you will find the archive version of today's workshop following today's presentation. We also do have several online on-demand training modules. These take approximately an hour to an hour and a half to complete, and they're written with a more beginning user in mind, so you don't have to be well versed in the energy code to find training modules beneficial for this. As far as we've made the transition for permits applied for beginning July 1st of last year, 2019, for the state of Illinois, and if you're in the city of Chicago, they moved a little bit ahead. So for theirs, it was permit applications dated June 1st, 2019 and beyond. They're on the 2018 version of the International Energy Conservation Code, along with the amendments. So one of the big changes that we saw in this code cycle is for those of you who may deal with state-funded facilities, could be community colleges, universities, or other state entities. So with this new revision here, the state facilities now have the same options as the rest of the state. Prior to this code cycle, they were required to use ASHRAE 90.1. They may now use either the IECC or ASHRAE 90.1. So a little bit more flexibility for those of you who may be associated with state-funded facilities. So rather than trying to write down all these web addresses or trying to remember them, these are linked through our website, again, SEDAC.org. So this provides links back to the 2018 International Energy Conservation Code, the online version, along with the Illinois and Chicago amendments. We do like to highlight that the International Code Council has done a very good job as far as making the codes accessible to people. They are available to view at no cost to people, and their search and find function is actually very well done. So it's not uncommon where if we get a code question, we may even go to the online version first rather than relying on the paper copy, just because that search and find function is so helpful to use. Helps you get right to the right place in the code rather than trying to page through your code book. So we do have several previous webinars that occurred this current program year. We are coming up to the end of the program year at the end of this month, and the next program year will begin July 1st. So these are some of the topics that we covered this year for the webinars. Again, if any of these are of particular interest, you may find the archive versions at our website. And while at our website, we do have the ability to register for our newsletter. In that newsletter, we will announce any upcoming trainings that we may have. So, as today we're going to be focusing on residential buildings and the residential provisions of the Energy Code. And the first thing we need to establish is, what is a residential building? Because the code is split up into the commercial provisions and the residential provisions, and we first have to identify which type of building we're in. You may have residential or commercial occupancies within a building, but first we need to establish the exterior of the building first. So here in the state of Illinois, there are some amendments to this, and so noting here one family or two family dwellings, or any building that's 3 stories or less above grade. In Chicago, you get an extra story, so 4 or less for Chicago, with multiple dwelling units in which occupants reside on a primarily permanent basis. The definition also has several examples listed, as you see here. The focus here being, are we on a primarily permanent basis? So hotels and motels would not be permanent basis, so those would fall under the commercial provisions. So as far as the provisions we're going to cover today, we have 14. Here's the first 7 that we're looking at the certificate and some low energy buildings, insulation and envelope sealing, blower doors, testing to verify our envelope sealing, fenestration, U factors, and for systems that may cover multiple dwellings. Also going to cover duct insulation and sealing along with the testing, pipe insulation, hot water circulation. That's been a little bit of a hot topic here lately. HVAC load and sizing, ventilation, lighting, and additions and alterations. Something else we should note, that towards the bottom of the your screen, if you hover towards the bottom, there should be some controls there, including a question and answer pane. So if you do have questions that go through, that you do have as we go through here, please go ahead and use the question and answer window so we can make sure that we capture those questions that you may have and make sure that we get them answered. Before we dive right in here, we do have a question that did come up as far as mid to high-rise apartment buildings. These are Mid to high rise, so if you are above 3 stories for most of the state or above 4 stories in the city of Chicago, then these are considered commercial buildings. And so you would begin in the commercial provisions of the energy code. There are segments of the commercial provisions that will refer back to residential provisions and vice versa. So just because that you are in the residential, if you are in a residential provisions, that doesn't necessarily mean you won't get referred forward to the commercial. So again, the threshold here is above 3 stories for most of the state and above 4 in the city of Chicago. I did have another question here, senior living. Here we're talking about that is predominantly permanent basis for senior living, so those would also be residential for those that are 3 stories or less here in the state of Illinois. So starting in with the certificate, code calls for a permanently posted certificate that covers several features of the home, and it calls out several things that need to be in it, and the location of this typically is going to be found either where the furnace is or in a utility room or approved location. So the 2 places that we normally find this is near the furnace or near the electrical panel. So those are the 2 places we typically find this posted. Obviously, we do not want to cover or obstruct other required labels. So such as on the electrical panel, if we placed it inside the door, we would not want to cover the schedule of the circuits inside. So here it does call out several things and features that need to be on it. You know, R values of the insulation, U values of fenestration and solar heat gain coefficients, any duct testing and air leakage testing that was done and the results therein, and the types and efficiencies of our heating, cooling, and water heating equipment. So here's a couple of examples of this. The one here on the left, this is a little bit older version of it. This is under the 2012 version of the code that this was generated, but most of the pieces of information are still the same even in the 2018 version. Just the minimum values or maximum values have changed over the code cycles. But these can take many different forms. You can see 2 examples here. I would note if I received the certificate on the left back in under the 2012 code cycle, I would be very suspicious of this because all the values noted here are exactly the minimum thresholds. And certain things such as the blower doors exactly at a 3.0 ACH or duct testing at exactly 4 CFM per 100 square feet. So a few of these would be very skeptical that they would. This is something that even if you're not necessarily required to provide this during a renovation or alteration, it may be helpful to go ahead and print out one of these and go ahead and fill in the information that you know. So if you're doing a project to replace fenestration, it might be good to go ahead and print the certificate out and write in what the fenestration U factor and solar heat gain coefficient is. An important reason that we have this certificate is on several things, such as the fenestration. Once it's been installed, that little label that tells us what the U factor was has long since gone. And so in case I break, I have a window break on me, I know the performance that I need to make sure that I replace it. Similarly, if the building has been improved, that may, when I replace my heating and air equipment, that may lead me to consider looking at downsizing the equipment. So in this instance, if I see the attic, listed as an R38, and then I go up in the attic and I find I now have an R60, that's shown me that something has changed and gotten better over the years. So these are some nice helpful things. These are required under new construction only at this time. But again, as I noted, if you do any alterations or renovations and touch some of these things, it'd be good to go ahead, even if you don't fill out the whole thing, and just fill out the ones that are part of your project. So that can be very helpful to a homeowner. So moving over to low energy buildings, this is a classification of buildings found in the code. So if you do a high performance building or a low energy building where your peak design heating or cooling is below 3 BTUs per square foot per hour, or 1 watt per square foot for space conditioning, that exempts you from the building thermal envelope provisions. So that can make some things a little easier to achieve and doesn't require as much documentation, which can simplify some of the construction. So one benefit of doing a high performance building, and as we can see here, some high performance buildings don't even necessarily have to look unusual to be high performing. The building on the right here is a facility that actually meets passive house. So it has extremely low energy intensity, but doesn't look terribly out of place, other than it's a little bit more of a modern looking building. As far as insulation, looking at the prescriptive method, we do call out that for this table here, there is an Illinois amendment for zones 5, or for zone 5, for basement walls. There's a little bit of an amendment here. We also note that if you have a heated slab on grade, then you do need to add some additional insulation. And again, what the objective here is, because the ground temperature tends to be much cooler, we don't want that heat going into the ground. We want the heat entering the building. So providing that thermal break between the heated slab and the ground. Heated slab typically is either hydronic or electric resistance coils that are in the slab itself. Is normally how that's done if you have a heated slab. So we do have a few notes throughout here for res check, where we do have some unique things that we do want to call out for those of you who are using res check for your compliance method, which res check is a prescriptive performance method, or it's a prescriptive method. It is not part of the performance methods found towards the end of the residential provisions. So here noting that the res check does not account for Illinois amendments. So you may have, res check may show that your insulation is not code compliant, even though it may pass the Illinois Energy Code because of the slightly reduced insulation requirements. Here noting in zone 5A, normally it had called out for either a 15 or 19, depending on where you were, or whether you were using cavity insulation or continuous insulation. Illinois has an amendment down to a 10/13. What a slash rating, such as the 10/13, is that is either a 10 continuous or a 13 cavity insulation. So if you see those slash ratings, it depends on whether you're using cavity insulation or continuous insulation. One thing we do like to call out is this table, R402.1 Low. This has two halves to it: air barrier criteria what we're going to focus on at this part in the presentation is insulation installation criteria. Most errors that we find in buildings or indoor air quality issues normally is a failure of one of these areas that was not followed correctly. And so if you end up with mold in several areas, this is likely a first place to check to see what went wrong. So this is a good checklist if you're going through to verify that you have accomplished things well. And this is just a fraction of this table. As far as insulation installation, here noting there are 3 grades of installation. Grade 1 is everything was done correctly. We have encapsulated insulation on all 6 sides, top, bottom, and all 4 sides. Made sure that it's cut correctly around junction boxes, split around wires. So this is a great installation. That's a grade 1. Moving all the way down to grade 3, that means either I've got up to 2% uninsulated or 5% improper insulation. So you can see all the way from the best to the worst is a difference of just a couple of percent. So that's very critical to note just how getting the details right on insulation can be. So here's a look at where you can see some missing insulation on the left where the bat didn't quite reach the ceiling or the top of its cavity. And on the right, you can see it's been compressed. So these are 2 common errors that we see as far as installation goes. Some others would be splitting the bat so that you have half the bat behind an electrical wire or plumbing and half in front. So here I noted earlier that we do have an Illinois amendment, and noting here that slash rating that I had talked about earlier, a 1013 is a 10 continuous or a 13 cavity. And that continuous insulation can be either on the front or the interior of the wall or the exterior of the wall. And so a 15/19 here as we go forward, Illinois does have a provision where basement walls normally have to go down to 10 feet or within 6 inches of the basement floor. Illinois does have a provision to allow you to reduce that down to only 4 foot below grade if you increase the insulation from the required value. So as we saw here, moving from a 1013 up to a 1519. So if we increase the amount of insulation, we don't have to go as far into the ground with it. So helpful little feature for that. As far as air leakage, so we want to make sure that we have prevented air leakage. That was one of the largest improvements in the code here a couple of cycles ago, was tightening our thermal envelope. And first we want to identify where our thermal envelope is, because we want the thermal boundary and the air barrier to be in intimate contact with one another. If you have a thermal boundary that air can pass through, it dramatically reduces its effectiveness. So we want those two, touching each other. So here we have 3 examples where the building shape is the same, but we have very different thermal envelope or thermal boundaries drawn in here. So once we identify where our thermal envelope is, then we know where we need to make sure that we go seal. So first we want to install the air barrier properly, and this air barrier should be continuous. Failures of air barrier normally lead to mold issues because with air comes moisture and humidity, and that moisture can condense inside that wall. So we want to make sure that we get that continuous air barrier all the way through, and any penetrations such as around outlets, receptacles, switches plumbing penetrations and anything like that, that we seal that back up. Once we have installed the air barrier, then we want to test it. And here in the state of Illinois, we have a limit as far as 4 air changes per hour. In the code that is unamended for our region, it would be 3 air changes per hour. So we have a little bit more leeway at this point. And noting that we do need to provide a written documentation of our testing as well as the results therein. And so noting here, if you look at the general requirements, noting again, we want it to be continuous and that we seal any breaks or joints. Rarely do things leak in the middle of a flat surface. It's normally corners, joints, and anywhere that you have a discontinuity. That's where you're likely to have a problem. It's a good document put out by the U.S. Department of Energy as far as air leakage. Tighter homes, we want to make sure that we build them tight and then ventilate right with homes. And so tightening homes and allowing us to choose how and where to ventilate is important, as well as likely to lead to a much more comfortable home. So many ways that you can do this: caulking, sealants, foams, going around and making sure wherever we have dissimilar materials or 2 similar materials coming together. On the left there, you can see where 2 boards come together. There's a joint between there, and making sure that we seal all of those up. So many different common leak locations around piping, recessed cans in soffits and kitchens. That's a large one for a previous area. And again here, noting that ResCheck does have a different standard for it. It is going to assume a 3 air changes per hour, whereas the Illinois does allow for 4. Normally this is not really, doesn't come into play, but if you're trying to use a performance path, it doesn't allow you to adjust this if you build it better than the code requires. As far as air leakage, so now that we've gone through and we've installed our air barrier, next we have to test it. So this is mandatory for new residential construction, and noting here again 4 air changes per hour when tested at a pressure difference of 50 pascals between the inside and outside condition. The code official can require this to be done by a third party, and that is likely to everyone's benefit to have this done by a third party. It doesn't make a lot of sense to have whoever is in charge of making sure they make the air barrier to test to make sure they passed it. So having that third party is beneficial. And we want to make sure that we test it at the correct point in construction, which is after all the penetrations have been made. It doesn't make a lot of sense if you test your building and then you go ahead and make your holes for your plumbing and electrical and HVAC and punch a whole bunch of holes after you've said, I have a tight envelope. And on some high performance facilities, we actually have seen this done multiple times during construction just to verify there hasn't been any rogue penetrations that may have been made. In multifamily housing here in the state of Illinois, rather than using the air changes per hour or a volumetric measurement, because smaller units have a problem between volume and surface area, and really what we're after is, did we create a tight surface? And so for multifamily, there is a testing method to allow you to measure the air leakage based on the surface area rather than the volume of the space. So 0.25, and if you're building more than 7 units for a development, you can do a sampling methodology for that. So this is actually a much more accurate measure for envelope tightness than the volumetric measurement. So before we get too far here, let's go ahead and we'll do a couple of poll questions here and check and make sure that we're staying on track here. So first, talking about which of the following attributes are required on the energy certificate. And second is, what is the maximum air leakage under the prescriptive compliance path in the state of Illinois?
We've also had a couple questions come in that I'd like to touch on. One that came into the chat instead of the Q&A window was for the building compliance certificate, should that be included on the drawing so that contractors know what they need to show?
That could be a helpful thing. It's not required to be on the drawings. However, if a design professional wants to go ahead and identify that and basically put in the prints, here's what the certificate should look like, that would certainly be potentially beneficial to the construction team.
When I was doing residential testing, probably about 7 years ago now, whoever was doing the pressure testing for the building would be the one that would generate that certificate. It's another way to go about that compliance, since they're getting those air leakage numbers, and usually doing some sort of, for our program, we were doing modeling with REM rate. So we were producing that certificate already and installing it in the buildings. So that is another method if you want to pick a contractor, probably the ones doing the leakage testing, to do that documentation.
I have a question here about blower door testing and if that's only for new construction. Yes, blower door testing is just for only required at new construction. However, air sealing is still required even for additions and alterations, but the testing is not required for that.
We also had a question about basement insulation requirements. Is that only for occupied basements or also for unfinished basements?
I do not believe it states that it is only for finished basements, so this would include unfinished basements. Presumably at some point in the future, the basement will end up becoming finished. So that's, I would have to verify that in the code, but I don't believe it states that that is, that would depend on where your thermal envelope is. So if your basement is not in your thermal envelope, and therefore all your insulation and air sealing is at the floor of the first floor, then yeah, you would not necessarily need to carry that insulation around. Again, that's where identifying where your thermal boundary is critical to start from, so you know where that insulation has to be. As far as Energy Star is not necessarily more restrictive than the 2018 IECC. It is a similar program, but it is not necessarily more restrictive. And Energy Star has changed its requirements here in the last few years. So Energy Star has gotten much more flexible. So complying with Energy Star does not necessarily, it doesn't qualify you as compliance with the IECC at this time.
Okay, we're gonna end our poll here now and check the results.
Okay, so on the what's required on the certificate. We've got everyone got R values, yes. U values, yes. Square footage of the building is not required to be on there. Heating and energy or HVAC efficiency, yep. Annual energy cost is not, renewable energy is not, and our air leakage tests are. So pretty much everyone got fairly good at that. So yeah, those 4 items do have to be on there. And compliance for Illinois, maximum air leakage, pretty much most people got that one, 4 air changes per hour. So yes, 5 is what the standard used to be. It's presently 4. If you look in the code without any amendments, it states 3, and that 0.6 is for passive house. So pretty good.
We did have one more question I wanted to touch on for foundation insulations, particularly radiant slabs. We had this question come in. I understood you can either insulate the perimeter or under, or a combination of both. Generally recommend the perimeter insulation at R10 down 4 foot minimum is what I recommend, and nothing below. Does that still meet the intent of the code? Insulation at 8 foot below grade does little to improve efficiency, if not a highly needed thing. So to that point, the code states that if you have a radiant slab, you have to have R5 under the full radiant heated area of the slab, and I believe it's an additional R5 on the perimeter insulation. So it's both in combination per the code, not either or. And that is the entire perimeter of the slab, I believe, to check the depth on that real quick.
I have a question here about an existing 2-story 2x4 frame. We'll touch a little bit more on that towards the end as far as existing and how you deal with compliance for that. So we will touch on a question regarding 2x4 existing framing.
And for your radiant slab, insulation does not need to extend below the slab, so it's to the base of the slab.
So with that, we'll go ahead and keep trucking along here. So overall, we're doing all right. Maximum fenestration U factors. So this is in case you're doing a simulated performance or UA trade-off. The code does call out that there is a maximum U factor that you may have area weighted wise. So for vertical fenestration or windows, maximum of 0.48, and for skylights a maximum of 0.75. Noting here that while the code does want to give some leeway to trade off and make other things better, you can reach a limit on that and cause other problems if you don't. So there is a maximum out there, even if you're using performance. For systems that may serve multiple dwelling units, and so this applies for service water heating or HVAC equipment, and here noting that if you're serving multiple dwelling units, then you have to comply with the commercial sections, C403 and 404. So as noted here, you may be in a residential building, but end up being referred back to the commercial provisions. So if you do have service water heating or HVAC that serve multiple dwelling units, you now get referred back to the commercial to do with that.
Okay, and I will take over for the mechanical sections of the residential code. First thing we'll touch on is duct insulation requirements. Prescriptive requirements require supply and return ducts in attics to have a minimum of R8 insulation if the duct is greater or equal to 3 inches in diameter, and a minimum of R6 for ducts that are smaller than 3 inches. If they're in other unconditioned areas other than the attic, such as a crawl space or an unconditioned basement, then those drop slightly to R6 for the larger ducts and 4.2 for the smaller ducts. And we've put a summary table here for reference in the future with various locations and the insulation requirements. The exception to that being, if all your ducts are completely within the thermal envelope of the building, they do not require duct insulation because any heat loss from the duct work or cooling loss from the work is into your conditioned space. So it's still conditioning the inside of the building. All ductwork in residential needs to be sealed. These are some good examples of using mastic, caulking, and UL 181 approved adhesive tape to seal up joints in the ductwork. Also following, especially with flex duct, connecting to hard duct manufacturer installation instructions. Usually they require a zip tie tightened to a certain tension and then covered with a mastic or a tape or something. So duct sealing, very important. Because you want to get the air that you're conditioning throughout the house to prevent having hot spots, cold spots, comfort issues, and to increase the overall efficiency and operation of your HVAC system. Duct pressure testing is mandatory for new construction buildings. You can have that testing done at 2 different times, either a rough-in test before all the drywall and everything is finished in the house, or the post-construction test when the house is just about ready to be occupied. If you're doing the rough-in test, again, both of these tests are at 25 pascals of pressure difference. All the ductwork should be taped off so that it's isolated from the interior of the house, and it creates an enclosed system to do that pressure testing. If ductwork is all entirely within the thermal envelope of the house, then you do not have to do pressure testing because any leaks, again, are inside the conditioned area of the house and assumed to condition that space. Also, duct testing is not required on ducts that serve energy recovery systems. So if you've got an HRV hooked up to your furnace, those connecting ducts do not need to be tested for leakage. A written report of those test results does need to be included and provided to the code official. And it's also included on the certificate that is included, the compliance certificate for the house. So just an example of what that pressure testing looked like schematically. You're going to seal up all return and supply registers. You're going to pressurize that ductwork to 25 pascals. Usually that's done with a small connected fan that's tied into the ductwork. Pressurize that ductwork and get a pressure reading. And that must be, real quick here. For the rough-in test, duct leakage should be less than or equal to 4 cubic feet per minute per 100 square feet of conditioned floor area. If you're doing that rough-in test before the furnace is installed to the ductwork, you'll test the supply ductwork, then the return ductwork, add those 2 results together, and that result should be less than or equal to 3 cubic feet per minute per 100 square feet of floor area. If you're doing the post-construction test, that furnace is going to be in place, and that requirement is, again, that 4 cubic feet per minute per 100 square feet. Why is duct pressure testing become so important? Over the years, we've done testing and analysis and discovered that that unsealed ductwork can have detrimental impacts. Here you can see a thermal image of a return duct in a wall that's drawing attic air into that return system. Not only is that increasing the load that unit must now condition, it's also drawing in impurities and dust and things from that attic space. Another thing, very important, you can put ductwork within a framing cavity, but you cannot use the cavity itself as the ductwork. So panned-in ducts where a metal sheet's been nailed over top of a framing cavity, using that cavity as a duct is no longer allowed. Again, the primary reason for that is it's very difficult to seal those properly, and you introduce a lot of impurities into that duct system with all the penetrations that go through that ductwork. some of the preservative adhesives and things like that used in flooring and framing cavities. And so that's why ductwork now has to be completely enclosed and then installed within that cavity instead of using the cavity itself as the duct. Another note here again, if you're using that performance compliance path for ResCheck, it is a fairly limited performance compliance path. It does not allow you to trade off air leakage rates in the ductwork or the building envelope. If you are going to be trying to use those to trade off energy performance for other areas, you'll want to use a program. We've listed a few here: Treat, HEED, or REMrate. They all do full energy modeling of the house and can get you results that will allow you to trade off duct leakage and air leakage through the envelope. Moving on to pipe insulation requirements. Mechanical system piping capable of carrying fluids greater than 105 degrees Fahrenheit or less than 55 shall be insulated to an R value of not less than R3. One of the places that we see commonly missed with this is the hot suction line on AC units, especially where it's running inside the house. Usually it's left uncovered. It should be insulated because that can reach higher temperatures close to or exceeding that 105 degrees Fahrenheit. And also, you're radiating that heat off that pipe back into the house that you're cooling down. When it's outside the house, it's not as much of an issue. It kind of acts as like a pre-cooler for your AC condenser unit. But per code, all that refrigeration piping and hot suction line piping needs to be insulated. Another important component, if that is outside the envelope of the house and exposed to the weather, it needs to be protected from the elements, particularly mechanical damage and UV degradation. It's not uncommon to see that foam pipe wrap dry rot over time and flake off the lines, and then you don't have insulation anymore. And there are UV protective wraps and things that can be added to the outside of that. There are also paint-on coatings that all add that UV compliance to that insulation. As far as hot water pipe insulation goes, insulation for hot water piping should have an R value not less than R3 applied to piping that is greater than 3/4 inch in diameter based on its nominal diameter listing. Piping serving more than one dwelling unit needs to be insulated regardless of size. Piping located outside of conditioned space needs to be insulated. Piping from the water heater into a distribution manifold, commonly missed, so it's listed here specifically, requiring to be insulated. Piping located under a floor slab. Again, you're trying to isolate any heat losses to the cooler ground temperature. Any buried piping, again, that ground temperature disconnect. And supply and return piping in recirculating systems other than demand recirculating systems. Recirculating systems being ones that recirculate water continuously. Demand ones have that exception because they're not circulating that water continuously and thus have fewer losses overall. We did get a comment that we commonly don't see plumbers insulating their hot water and cold water pipes. Would that be outside of code? Again, it goes back to primarily the pipe size. If it's smaller than that 3/4 inch diameter nominal size, they are not required. So if it's a 1/2 inch pipe or something, which is not uncommon to see in smaller residential construction, that would not need to be insulated per the code. Although best practice would indicate that it should be. Moving on, looking at domestic water circulation and demand recirculation controls. We want to note here specifically for both these systems, there is a demand component. So R402.1 and R402.5.3, primary being for circulation systems, the second being for demand recirculation systems. Both of these include the requirement that before that circulating pump kicks on, there needs to be an identified demand for hot water flow. So that is important to note that if you're going to install these in the building, you have to meet these requirements. That demand needs to be identified. And for recirculating systems, demand recirculation systems, if you're using that cold water piping as your common return for hot water, you also need to shut off that pump when that cold water return line is 104 degrees or hotter. That way you're not overwhelming that cold water and still have immediate access to cold water supply as well. Some examples of what those different systems look like. On the left is the dedicated hot loop recirculation system. And on the right is your demand recirculation system, where you've got a pump out in the system. Usually it's at the farthest leg of your hot water supply line. And anytime one of those faucets kicks on, or a sensor detects that someone is using hot water, that pump kicks on to recirculate. For the circulation system, that's a dedicated hot water loop. Usually that flow sensor is going to be on the inlet line to the hot water tank, because as you're drawing hot water out of that tank, you're going to be drawing in cold water to refill it, and that's going to be your identification of hot water demand in the building. Moving on to, before we move on to this next session, we do have a couple more poll questions we wanted to touch on regarding duct testing and pipe installation. So I'll launch those, and it'll also give us a chance to catch up on a couple more questions that have come in. So our first question is, under which condition is duct testing not required? And our second question is, when is domestic hot water pipe installation required? So if you all want to start answering those, we will look at a couple of questions that have come in. Is duct testing mandatory for additions where you are installing new upgraded furnaces? So if you're only upgrading the furnace and installing that furnace and not touching the rest of the ductwork, duct testing is not required. And actually for any alterations, duct sealing is required, but testing is not. The only difference in the IECC, Illinois amendments have removed this, but the IECC straight, reading that text, I believe it's a 40-foot length would have to be tested, but again, Illinois amendments removed that. So in the state of Illinois, duct testing is only required in new construction ductwork. We also had a question about, is ResCheck still a viable software to use? It is, depending what you're using it for. It is primarily based around prescriptive compliance or the UA trade-off for envelopes. It does have that performance compliance alternative, but it is very, very limited in what you can trade off. Primarily, again, it's focused on envelope trade-offs. If you're wanting to do more trade-offs as far as air leakage through the envelope, air leakage through ductwork, you're going to want to use another software to do that. But if you're primarily focused on prescriptive requirements and you're wanting to do UA trade-off, it does work very well for that purpose. So R402.1 take a quick look at those while our poll is wrapping up here. So heated water circulation and temperature system maintenance systems in R403.5.1 are listed as mandatory if they're installed. So if you don't have a recirculation system, you don't have to meet those compliance requirements. But if you install a recirculation system, one of those options becomes mandatory depending which method you're using. So if you have a circulation system, you would have to meet 403.5.1.1. If you're doing the demand recirculation, then you have to meet 403.5.2. The reason they're not individually listed as mandatory is because the main head section 403.5.1 calls it out. Okay. Looks like most people have answered the polling questions. We're going to share those results now. Under which condition is duct testing not required? Ducts inside the thermal envelope, ducts and air handler inside the thermal envelope. The correct answer is the ducts and air handler have to be within the thermal envelope. I apologize, I did not state that clearly when I went over that slide. But the entire HVAC system has to be within the thermal envelope in order to not require testing for leakage. Point number 2, when is domestic hot water pipe insulation required? Looks like most people have understood that almost all of these, the 3/4 inch, serving more than one dwelling unit, located outside conditioned space between the water heater distribution manifold, located under a floor, buried piping, supply and return piping, and a recirculation system, all of those are required. The only incorrect answers are always and never. So most people got that right. We started to trail off towards the end of that list, but all of those are requirements for requiring pipe insulation. Moving on to HVAC equipment load size, load and sizing requirements. This is kind of a fun example of something that Ryan has said he's actually seen someone use. You would hold this card out in front of your face, line it up on the front of the house from across the street, and match the front of the house size to the most closest size in this card punch out. It didn't take into account the depth of the house or anything like that, but that's how they used to size HVAC equipment. More commonly, what we see is this rule of thumb for residential HVAC sizing, where 1 ton of cooling is required for every 500 to 600 square feet. However, with improvements in air tightness, insulation requirements, and things in the code, that rule of thumb rarely, if ever, applies anymore. And so now we say that rule of thumb just doesn't always work. You can see here, this came from a blog post from energyvanguard.com. It does a lot of posts about residential construction and energy efficiency. They actually did testing on their houses to see how closely they aligned with this rule of thumb. That red line at the bottom is the rule of thumb requirement, 500 square foot per ton of cooling. And you can see everything is beyond that. And most of them are well beyond it, almost twice or higher. So it's very important to do proper load sizing calculations for your equipment. How do you do that? For residential buildings, ASHRAE's produced the Manual J document. It is the sizing procedure for determining HVAC loads in your house based on the envelope, insulation levels, fenestration, and air leakage. They do have a handy quick calculator online that you can use to do these calculations. And then to size the equipment and install it after you've got a load calculation, you would use the ASHRAE ANSI Manual S. And that takes your load calculations, you input into this. It accounts for equipment efficiencies and distribution efficiencies, and gives you what you should size your equipment to meet those loads. And usually it's the next size up that matches your load calculation from the Manual J. So here we're showing those technical manuals cover design, installation, maintenance for residential. They also have manuals for commercial systems. For those of you that are also heavily involved in commercial construction, the manuals have different names. J becomes N for load calculations. Equipment sizing becomes CS for commercial instead of just S for residential. One thing we would like to call out, though, is there is also a Manual D for residential and Manual Q for commercial for duct sizing. Although it's not a requirement of the code, it can be very beneficial because it helps ensure that um, the airflow through your duct system is going to be evenly distributed and meet the individual space loads within your structure. Um, it's not uncommon for a lot of residential buildings to see balancing dampers put in the ductwork, and on callbacks from the customer or during finalizing the house when it's they're doing final touch-up painting and things like that, they'll adjust those dampers in order to balance the airflow. Where if they'd done a manual D calculation, they wouldn't need those at all. The ductwork would be properly sized to evenly distribute airflow throughout the house. So we do like to highlight that manual D is an option and can potentially reduce callbacks and issues with uneven heating and cooling within structures. So again, covering why the emphasis on sizing of equipment. We've got significantly improved thermal envelopes with higher insulation values. We've got significantly improved air tightness. And so we're not having to oversize equipment to account for leakage through the building. We've reduced natural ventilation and we're going more with controlled ventilation. Rooms have much lower loads as far as lighting and plug-in electronics as those have become more efficient. And we're retaining more moisture within the house in the wintertime, and we're not drawing as much moisture in from outside in the summertime. So we've got much lower humidity loads. All of these have a dramatic impact on the sizing of the HVAC equipment. As far as when are size calculations required, new construction, obviously, if you're doing an existing remodel where you're completely replacing a furnace or HVAC equipment, it should also be done then. It is in the R502 for alterations and additions, R502 for additions, R503 for alterations. If you're changing the load in the house, you're going to have to do a calculation and match your system to that potentially, or add a supplementary system to cover that addition. If you're replacing an HVAC system, you are required to do a load calculation on the existing structure and properly size the replacement equipment. Another thing we'd like to call out for manual J outdoor load calculations, ASHRAE produces these design temperature charts. They are included in the manual J. They're also included in ASHRAE fundamentals books, and I think on in the front of the IECC as far as design temperatures for the different climate zones and regions. But we would like to call out that none of these have a design temperature of 100 degrees. If you get a manual J that has that as a design temperature, send it back, it's not correct. What we're sizing for with the manual J is that 95, in this case 99% condition for cooling. We're not designing for the absolute hottest day of the year. We're designing for, what's typical, and then the system should run continuously at that design condition and beyond if it gets warmer, and still be able to maintain comfort, although your house may warm up slightly. But it's such a rare event that you don't want to over design your system to cover those very rare events, and then have for the rest of the year an inefficient system. We did have a question about natural ventilation reductions with regard to system sizing. Does that mean opening windows? Don't we want to rely on mechanical ventilation in residential as little as possible? The thing with natural ventilation is it's inconsistent. It relies a lot on wind direction and wind speed. And for large components of the year, it's too hot or too cold to leave a window open and rely on natural ventilation. So you have to have a mechanical system that's designed to mechanically ventilate during those times when you can't bring in natural ventilation. And so that's why systems are designed and sized now based on that mechanical ventilation requirement. Although yes, when it's temperate enough outside, we would like to see people relying on free cooling and natural ventilation. As far as can ResCheck be used in place of a manual J or S? No. It is not a sizing software. It does not do load calculations. So you could not use that to replace a manual J or manual S. Programs that could be used, REM rate, heat and treat, they all do load sizing calculations. I believe they're all certified as acceptable programs to do a load sizing calculation. So moving on to ventilation types for buildings, there are 3 different schools of thought on how to ventilate buildings. You've got negative pressure ventilation, where you've got an exhaust fan that runs, depressurizes the structure, and you draw in fresh air through leaks in the envelope and open windows and doors, essentially relying on leaks, gaps, and cracks to draw in that fresh air. The other option is positive ventilation, where you've got an outside air duct, usually tied into the return side of your air handler, so that that fresh outside air is brought in and conditioned and dehumidified or heated up as needed, and then distributed through the building. And then again, you're relying on leaks, gaps, and cracks in the envelope and some mechanical ventilation to relieve that pressure through the building. And then there's the balanced alternative where you've got an ERV or 2 fans, a supply and an exhaust that are bringing in outside air balanced with the amount of exhaust air going out of the building. Exhaust ventilation only is probably the most common and probably the least expensive option for doing ventilation. We do note, though, that it does have some potential issues in that you're relying on gaps and cracks in your building envelope to replace that exhaust air with fresh ventilation air. And so you do have that potential to draw in moisture into your wall assembly and have condensation issues, things like that. It can be designed effectively, but you have to be very careful with where that air is coming into the envelope and how your envelope is set up to handle those leaks. Probably the next option that we see is supply only. This one actually seems to me to be more rare, probably because with this system, you've got to add a timer to your supply fan on your residential system so that it's bringing in outside air on a regular basis for ventilation purposes. Because especially in mild weather, your furnace fan isn't normally going to run enough to draw in that ventilation air into your building. So to meet the required ventilation air change rates for fresh air, there's usually a timer added on to your furnace. You can see in the middle picture, it's highlighted there on the furnace, that opens a damper and kicks on the fan to bring in that fresh ventilation air, even if there isn't a demand for that unit to run for space conditioning purposes. And so that's probably why this one isn't as common. There is that additional design complexity in supplying that fresh ventilation air. Probably the second most common, just because of the efficiency gains you get from it, is the balanced ventilation system. You've got an exchanger, either in a crawl space, a mechanical room, up in the attic, that is exchanging heat, and for a full energy recovery one, it's also exchanging moisture between the exhaust air and the incoming outside air, so that you're minimizing how much you're having to condition that air and minimizing the energy that the HVAC system needs to consume. This is the best method for doing ventilation in a building because it minimizes the risks the other 2 methods have as far as pushing air through leaks in your building envelope. And it also minimizes the long-term energy costs for the client. The one thing we do like to point out is if you're going to install one of these, it does require maintenance. The filters have to be changed on the heat exchanger. You want to put it somewhere where the occupant is going to know about it and be able to do those filter changes and regular maintenance on the system. If you put it in a crawl space or an attic where it's hidden and forgotten, it's very likely that somewhere down the road there's going to be an issue with that system where it's not going to work properly, and then you're not going to have your design ventilation for that building. Some Illinois amendments not included in the 2018 IECC. Most of these are pulling in requirements from the residential codes or mechanical codes. Just for reference purposes, they are noted by reference in the IECC, but the Illinois code pulls them in so that they're all in one space. So these aren't impacting the code at all as far as changing the requirements. They're pulling in those other parts of other codes that are related to the energy code, as far as ventilation rates, recirculation of air, things like that, so that it's all in one document. I did have a question about air changes for multifamily building residential code application. Is the 4 air changes per hour required for each individual residence or for the totality of the building as if it were one large residence? Is it okay for a large amount of infiltration to transfer from one dwelling space to the adjacent dwelling space, or does each dwelling space have to be airtight? So this is where the Illinois amendment kind of comes in and is helpful, where you're testing the envelope area of each unit, because you're testing that leakage rate based on the square footage of the surface area instead of the volumetric requirement, and it does provide a little more leeway in compliance. It's a little easier to meet that envelope leakage requirement than it is the volumetric requirement for small units. However, if you are using that volumetric requirement or the space requirement, I believe it is a sheltered test where you have to do the pressure difference in each individual unit. I think Ryan is looking that up and can touch on that.
Yeah, that's correct. That the you can test the individual units and use the surface area method, which is likely to be easier to achieve, or you can test the entire building and use the volumetric 4 air changes per hour. So for construction and long-term durability, we would encourage the use of the surface area rather than the volumetric, just from the standpoint of, from a building owner's perspective, you don't want to necessarily leak odors and smells from one unit to the next. And so relying on the surface area test is going to be beneficial for you as the owner.
And one question on mechanical systems: is it necessary to have an air balancing test in a residence? Again, this is not required in the residential code to do air balancing like it is in the commercial code, although it would probably be beneficial to start that as best practice. It is not a code requirement, no. Moving on to residential lighting requirements. Pretty short and simple. There is an Illinois amendment on this that adjusts slightly the requirements. But overall, you just have to use high efficacy lamps in no less than 90% of the permanently installed fixtures in your residential structure. What is a high efficacy lamp? For individual lamps, the efficacy is 65 lumens per watt. For individual fixtures, it is 55 lumens per watt. Also, one note, the low voltage exception has been removed from the 2018 IECC. So no longer can you have track lighting all over the house that is not included in your overall lighting count. And so this high efficacy requirement now applies to all lighting within the residential structure. Another note, if you've got recessed luminaires, they have to be airtight fixtures and they have to be sealed properly. Again, maintaining that thermal envelope of the building and maintaining that those air leakage requirements. Moving on to additions and alterations. This is our last section and probably the one we get the most questions on. Covering additions first. Additions to an existing building system, or portion thereof shall conform to the provisions of the code as they relate to new construction. Unaltered portions of the existing structure do not need to be brought up to code. So there are a couple of ways to kind of look at this. You can do prescriptive compliance for the addition and test it and everything independently, as far as meeting R value requirements, making sure the envelope is sealed, making sure any new ductwork is sealed. But again, additions to existing structures do not have a requirement for air leakage testing or duct leakage testing, the duct leakage testing being an Illinois amendment. However, if you want to do performance testing on the entire building and comply with the additions through a performance path method, then you are going to be probably doing pressure testing and duct leakage testing and things to maximize what you can trade off for that addition. But you have to show that your overall addition and original building is using less energy than the original structure. For alterations, alterations to any building structure shall comply with the requirements of the code for new construction, with the exception that they cannot cause a hazard or overload existing structures, and they also cannot be, if you do an alteration, it cannot be less conforming than the strict existing structure of the code. So you couldn't like remove a layer of insulation and leave it off. You would have to return to at least the original level of insulation. Probably the most common question we get on this is for roofing insulation, for above deck roofing. To add the full code compliance, often there are restrictions such as parapet walls, flashing, other restrictions on the roof. So the way the code is worded for alterations is that you have to add as much insulation as you can within the existing constraints of the original structure. So you're not required to raise parapet wall heights or move a window or something like that where you've got a flashing restriction in order to put in the full depth of insulation. You're allowed to put in just what fits within your existing given constraints. For commercial buildings, a very common thing is HVAC roof curbs. Not as common in residential buildings, except for probably larger multifamily buildings. Exceptions to alterations, things that are not required to comply with the code: storm windows over existing fenestration, existing ceiling wall or floor cavities that are exposed during construction, just have to have the cavity filled. You don't need to fur them out to add full prescriptive requirement R values. Construction where the existing roof wall or floor cavity is not exposed, you don't then have to do anything with that cavity. If you're doing a roof recover where you're peeling off just the roof sheathing and putting it back down without touching the insulation or the roof deck, actually that's the wrong definition. Roof recover is just putting a new membrane or new covering over an existing roof. Roofs without insulation in a cavity and where the sheathing or insulation is exposed during re-roofing shall be insulated either above or below the sheathing. Surface applied window films installed in an existing single pane fenestration to reduce solar heat gain do not need to meet the requirements for solar heat gain and things like that as you're improving an existing structure. So these are just some pictographical images of those exceptions. Again, the first image there is a storm window. Second one is that window film covering. The picture of the guy installing insulation along the cathedral ceiling there. You've got an exposed cavity. You don't have to fur that out to get in additional insulation. You just have to fill that cavity. In the bottom right image there is a furred masonry wall. Those furring strips don't constitute a cavity that needs to be insulated. So you could reattach drywall over that without having to add insulation to that existing masonry wall structure. There's no cavity exposed that needs to be insulated. Roof membrane peel and replacement is an Illinois amendment to the code. It is very narrow, not likely to apply in most situations, as per the definition, this is where an existing weather-resisting membrane is removed, exposing insulation or sheathing, and only that membrane is reinstalled. You're not touching the roof deck, the insulation, any sheathing materials. All you're doing is peeling off the old membrane and laying down a new one. It is very rare to see that done before there is a roof leak of some sort. If there is a roof leak, you're generally going to have to do some remediation work within the insulation into the roof deck, and so this would then not apply. So just noting that this is an option, but it is very narrow, and we rarely see it applicable to projects. And here, clarifying again, for alterations to an existing building, if you're adding insulation, particularly to insulation above deck, you only have to add in the insulation that can fit within the existing constraints. In this example, to meet code compliance, you need to add maybe 5 inches of insulation to the existing 1 inch, but you've only got 3 inches available that you can move this flashing up and work with the existing parapet wall and meet the existing flashing requirements. So you'd only have to add the 3 inches, not the 5. And that would be fully compliant for an alteration to that building. So to finish off our presentation here, we do have a couple more poll questions that we'll launch. The first question is, which ACA manuals are required for energy code compliance? And they are listed there. Particularly, we want answers for the residential. And the second one is, if I need to repair, replace insulation or roof decking, can I still qualify for peel and replacement under the Illinois amendments? Let's see what questions we have had come in. Does wall, floor, or ceiling between 2 adjacent dwelling units have to be air sealed and airtight? So we kind of touched on this earlier. For air leakage testing in new construction, if you're doing the volumetric compliance method, you can test the whole building leakage, which wouldn't catch air leakage between units. But they do, I believe, still have to be air sealed properly. Part of that is, fire code. You don't want to have holes and things through separating walls between dwelling units, or you've got a fire path there as well. And so they should be airtight. And as Ryan noted earlier, you also don't want fumes such as odors and things from it transferring to a neighboring unit. Let's see. I haven't had any other questions come into the chat. We do have one here for engineers. Does the webinar qualify for a PDH certificate? If yes, how many hours will that be equivalent to? There is a completion certificate that will be submitted probably towards the end of this week after completing this webinar. And I think that will note 1.5 hours for this particular session. For continuing education units, and I believe that also qualifies for PDH, although that's self-reported for professional development hours. Any other questions to us, please submit them to the question and answer window. Looks like most people have answered the poll, so I'm going to share the results now. As far as which ACA manuals are required for energy code compliance, there are 2 correct answers here. Manual J looks like everyone got, and Manual S. Fewer people caught that one, but most people still got that correct answer. And then for question number 2, if you need to repair and replace insulation or roof decking, you cannot qualify for peel and replacement. So the correct answer there is no. The only time you can qualify for peel and replacement is if all you do is peel off the existing membrane and lay down a new one without touching anything else in the roof assembly. Okay. Then we do have one final poll here for everyone regarding the duration of this presentation and its content. If you could please answer that poll, we appreciate your feedback. Also, if there are any further questions, please let us know.
Once again, I do want to remind everyone, if you do need any technical assistance with the Illinois Energy Code, do feel free to reach out to us, energycode@sedac.org. So that's for any projects here in the state of Illinois, whether that's building owners, occupants, design professionals, code officials. We are here to provide technical assistance for anyone here with the state of Illinois.
All right. Seems we have no further questions at this time, so we would again like to thank everyone for attending today, and we hope you have a wonderful afternoon.